The internal combustion engine. It's a bit of a mouthful, isn't it? But it's the beating heart of most cars on the road today. This ingenious invention takes the energy locked inside fuel and transforms it into the power that turns your wheels. It's a fascinating process, and understanding the basics can deepen your appreciation for the engineering marvel under the hood. Now, don't worry, you don't need to be a mechanic to grasp the fundamentals. We're going to break down how it works in simple terms, starting with the core components. Think of it like this. The engine is like a well-coordinated team, with each part playing a crucial role. First up, we have the engine block. This is the heart of the engine, the core structure that holds everything together. This hefty piece of metal, often made of iron or aluminum, is the foundation of the engine. It's designed to withstand extreme temperatures and pressures. Imagine it as the team's playing field where all the action takes place. Without a solid engine block, the engine wouldn't be able to function. Inside the engine block are the cylinders, the chambers where the magic happens. These cylinders are meticulously engineered to ensure optimal performance. The number of cylinders can vary, with more cylinders generally meaning more power. Now meet the pistons. These are the components that move within the cylinders. These cylindrical components move up and down inside the cylinders like athletes doing lunges. Their movement is crucial for converting fuel into mechanical energy. They are connected to the crankshaft, a rotating shaft that converts the piston's up and down motion into rotational force. This force is what ultimately powers the vehicle. Think of the crankshaft as the coach directing the team's efforts into a unified movement. It ensures that all the pistons work together harmoniously. Finally, we have the camshaft, another rotating shaft that controls the timing of the valves. The camshaft is essential for the precise operation of the engine. These valves, like gatekeepers, regulate the flow of air and fuel into the cylinders and the exhaust gases out. Proper valve timing is crucial for engine efficiency. The camshaft ensures everything happens in perfect sync, like a choreographer ensuring the team's timing is impeccable. Without it, the engine's performance would be erratic and inefficient. Now that we've met the key players, the pistons, valves, and spark plugs, it's time to delve deeper into their synchronized dance. Let's see how they work together in a four-stroke cycle, a marvel of engineering that powers our vehicles. It's like a well-rehearsed play in 4 acts, each one crucial to the performance. Act 1 is the intake stroke. Here, the intake valve opens and the piston moves down, drawing in a mixture of air and fuel. This is the first step in the engine's breathing process. It's like taking a deep breath before a big effort, filling your lungs with air to prepare for what's to come. Act 2 is the compression stroke. Both valves are now closed and the piston moves up, squeezing that air-fuel mixture tightly. This compression is essential for the power that will follow. Imagine a spring being compressed, building up potential energy. The tighter the spring, the more energy it can release. Act 3 is the main event, the power stroke. The spark plug ignites the compressed mixture, causing a controlled explosion that forces the piston back down with great force. This is where the engine gets its power. Finally, Act 4 is the exhaust stroke. The exhaust valve opens and the piston moves up, pushing the spent gases out of the cylinder. This clears the way for the next cycle. It's like exhaling after a hard workout, expelling the used air to make room for fresh oxygen, and then the cycle repeats thousands of times per minute, propelling your car forward with seamless efficiency. This continuous process is what keeps your vehicle moving, a testament to the brilliance of automotive engineering. All this action generates a lot of heat, so engines need a way to stay cool. That's where the cooling system comes in. The heart of this system is the radiator, which works like a car's version of a sweat gland. Coolant, a special fluid, circulates through the engine, absorbing heat. It then flows to the radiator, where the heat is released into the air. But heat isn't the only challenge. Engines have many moving parts that rub against each other, creating friction. That's where the lubrication system steps in, like a soothing balm. The oil pump circulates engine oil to all the moving parts, reducing friction and preventing wear and tear. The oil filter, like a sieve, removes any contaminants from the oil, keeping it clean and effective. Just like there are different types of athletes, each excelling in their own disciplines and showcasing unique strengths, There are different types of engines, each designed with specific purposes and performance characteristics in mind. One way to classify them is by how their cylinders are arranged, which significantly impacts their performance and efficiency. Inline engines, as the name suggests, have their cylinders lined up in a straight row. This simple and straightforward design makes them easy to manufacture and maintain. They are compact and commonly found in smaller cars where space efficiency and fuel economy are paramount. V engines, on the other hand, arrange their cylinders in a V shape. This configuration allows for more cylinders in a smaller space, resulting in more power and a smoother operation. This makes V engines popular in larger cars and performance vehicles where power and smoothness are highly valued. They are often found in SUVs and high-performance sports cars, providing the necessary power and torque for demanding driving conditions. Then we have the boxer engines, named for the way their pistons move like boxers throwing punches. This unique motion helps to balance the engine and reduce vibrations. Their cylinders are horizontally opposed, giving the engine a lower center of gravity and better balance. This design is particularly beneficial for sports cars, enhancing their handling and stability. Each type of engine has its own personality, its own blend of strengths and weaknesses. The choice of engine can greatly influence the driving experience and the vehicle's overall performance. Which one is best depends on the specific application and desired characteristics of the vehicle. Whether it's the simplicity of the inline, the power of the V, or the balance of the boxer. Each engine type offers something unique to the automotive world. Section 6. Boosting performance turbochargers and superchargers. Now, imagine giving our athletes a performance boost. That's what turbochargers and superchargers do for engines. These ingenious devices force more air into the cylinders, allowing for a bigger bang and therefore more power. Turbochargers use the engine's exhaust gases to spin a turbine, which in turn drives a compressor that forces air into the engine. Superchargers, on the other hand, are driven directly by the engine's crankshaft via a belt. They provide instant power boost, whereas turbochargers have a slight lag before they spool up. Both turbocharging and supercharging are like giving our athletes a shot of adrenaline, boosting their performance to the next level. Section 7. Timing is everything. Variable valve timing. Remember the camshaft, our choreographer, ensuring perfect timing? Well, variable valve timing, or VVT, technology takes this a step further. It allows the engine to adjust the timing of the valves, opening and closing them at precisely the right moment for optimal performance and efficiency. It's like a choreographer who can fine-tune the dancer's movements depending on the tempo and rhythm of the music. VVT allows the engine to breathe more freely at higher speeds, improving power output. At lower speeds, it can optimize fuel efficiency, saving you money at the pump. It's a win-win situation, making the engine more adaptable and efficient. Section 8. The future is hybrid. As we look towards the future of automotive technology, hybrid engines are taking center stage. These innovative powertrains combine the traditional internal combustion engine with an electric motor. It's like having two athletes working together, each playing to their strengths. The electric motor provides additional power and can even propel the vehicle alone at low speeds, reducing fuel consumption and emissions. The gasoline engine kicks in when more power is needed or to recharge the battery. Hybrid technology is an elegant solution, bridging the gap between conventional and fully electric vehicles. Section 9. Understanding your engine, a mechanic's perspective. Just like knowing a bit about your own body helps you stay healthy, understanding the basics of your car engine can make you a more informed and proactive car owner. It can help you identify potential problems early on, make informed decisions about maintenance and repairs, and appreciate the engineering marvel that gets you from point A to point B. So, next time you're behind the wheel, take a moment to think about the intricate dance of pistons, valves, and explosions happening beneath the hood. It's a symphony of engineering, and understanding its rhythm can make you a more confident and knowledgeable driver.